Hello everybody, welcome back. Today we're taking a look at a problem that you can solve using vectors. Okay, here we go. Find the distance from the point -2, 4, 5 to the plane 2x plus 6y minus 3z equals 10. We have a formula here that's going to help us out. So whenever you have a problem involving a plane, it's not a bad idea to find a point on the plane and find a vector that is perpendicular to the plane. So the vector we want is not too hard to get. Um, you can find it just by taking the numbers out from in front of the x, y's, and z's. And then this gives you a vector that is perpendicular to the plane. And a point on the plane, we have 1, y, we have 6. So if we combine that with 4, which means x equals 2 and z equals 0, then we end up with 10. So a point on the plane is 2, 1, 0. Okay. So how are we going to go about finding the distance from our point to the plane now that we have this? So the first thing that we need to do is we need to turn this normal vector, the perpendicular vector, into a unit vector, which means it has one length. So in order to do that, we need to find the actual length of this here. So the length is 2 squared is 4, 6 squared is 36, and -3 squared is 9. So if you add these all up, you get 40, 49, square root of 49, which is 7. So the length of this vector is 7. So in order to turn this into a vector of length 1, you divide each component by 7. So our new unit vector, which we will call u, is equal to 2/7, 6/7, and -3/7. Okay, so now we have a unit vector and we have our point on the plane and the point that we want. So one way to do this is to find a vector between the point that we want and the point on the plane. And you'll see why we do this. Um, it gives us a distance to the plane, if that makes sense. Okay, so we do that by taking this point here and subtracting this point from it. And you do that by subtracting each component. So we'll call this point P, we'll call this point Q. So our vector P to Q is equal to 2 minus -2, 1 minus 4, and 0 minus 5, which is the same as 4, -3, -5. Okay, now we have a distance to the plane, and we have a unit vector that's perpendicular to the plane. What can we do with that? That's where our friend the cross product comes in, or the dot product rather, comes in. Because this is the dot product is a way to tell how lined up two vectors are to some extent, and we'll be using that plus the normal vector to figure this stuff out. Actually, it's pretty clear to see if you imagine the situation, which if you can't, we'll get to that in just a second. But if you can imagine the situation, the shortest distance from any point to a plane is the distance. If you draw that line, the shortest distance, it's going to be perpendicular to that plane. So that's why we want to use the dot product, because we want to measure how lined up this PQ vector is. So we will do that here. PQ dot U, and we'll be using the first half of our equation here. We don't use the second half in this problem, but we could. Okay, so this is 2/7 times 4 minus 6/7 times 3. It's a double negative, so it's positive. Just to be consistent, 3/7 times 5. So you end up with 8 minus 18 plus 15 all over 7, which leaves you with, let's see, that's a negative 10, that's 5, okay, 5/7. And this is our answer here. It just kind of ends up popping out there. So let's take a look at this in a geometric sense. Okay. Yeah. Okay, so here is our situation here. A is the point that we want to find the distance to. Our plane is in the correct spot, and then this point here, B, is the point that we decided was on the plane. So here's our vector PQ. Okay, so the first thing we did was we found our normal vector, which we found here, and you can see it does go very perpendicularly into the plane and through it. The next thing we found was our unit vector here, which it's hard to verify, but this is a length of 1. This little arrow there has a length of 1. And then using the dot product, we measured how lined up they were. And that gave us the distance between these 2 points here. More accurately, if we were looking at it from like this direction, you can see like a right triangle, all that kind of stuff. So all in all, we found the distance between that point A and that point F, and the point F, if you take that line between A and F, it's perpendicular. So that is the shortest distance. Thanks for watching.